Hi, my name is David Larson from Beta Star Life Science Equipment, and today we're going to be talking about leveraging IoT and how to use IoT effectively for running efficient facilities and laboratories. To start off, we want to define what is IoT. It's a popular term used by many, but IoT stands for Internet of Things. It is a category of the digital revolution, an example of which is the smart refrigerator. If you walk through a Lowe's or a Home Depot or something like that, you'll see refrigerators with screens that can tell you when you need milk and eggs and do all kinds of things. But the smart refrigerator is one example of how IoT helps bring additional features and efficiencies to everyday life. And it helps make some of these tasks, these non-essential, non-value added tasks, easier. Okay, if I'm going to the grocery store, the less time I spend looking at do I need eggs, do I need milk, what's my list, is better. And that's where IoT comes in. That's why it's been accepted in things like refrigerators. Um, just as some concept after doing some research on how big is IoT now, the industry is expected to grow to $6.2 billion in the next 5 years. So you'll see it on additional, furniture that you have in your everyday home, and it'll be expensive to start off, but then the price points will continue to get lower, and that's how the industry will grow and gain wider adoption. But step out of the smart refrigerators and into laboratories and say, okay, how can IoT benefit a laboratory? And there are kind of three ways that we'll talk about today as we look at bringing this technology to use. The first one is kind of the need for efficiency. It benefits the bottom line to, as I mentioned, and it'll be a theme throughout, to spend time on the value-added tasks in a laboratory. Research should be where the focus is, and not managing the equipment like autoclaves and washers, which will be the primary focus of the adoption of IoT in today's discussion. The second point is kind of talking about how IoT helps in practical ways to say, hey, how can I use this to replace tasks? What tasks can I replace in my lab that I'm having to do manually? And the last one is kind of, hey, I like IoT. How do I get it into my laboratory? We'll talk about some ideas for execution for new equipment, but also on existing equipment. So you can bring it to your labs if you're not planning on making any capital equipment purchases in the near future. The overarching goal of implementing IoT in your facility is to spend less time, money, and energy on managing cyclical equipment. As I mentioned, sterilizers and washers will be a lot of the focal points of today's discussion. And more time spent on research and production initiatives, because in the end, that's what these facilities are there for. It's not to manage equipment, it's to spend time on research and production that will bring the next innovations in research. And for me, my goal is helping facilities to do that and to spend less time on these non-value added tasks. Because in the end, people that work at facilities, such as yourself, researchers, technicians, have unique skill sets. Okay, it shouldn't be spent managing sterilizers and things like that. We want to maximize the time that is spent on tasks that you and the rest of your staff, your coworkers, have unique skills to do. And IoT is about freeing up time and investment to reinvest in those activities, to spend less time managing the equipment and more time on the research. Some ways that we can realize these efficiencies, because I think one of the things that's important with new technology is, hey, how do we apply it? Okay, it's too often viewed as some theory or pie in the sky that looks at, okay, IoT sounds great, but what does it actually mean for me in my lab? So we're going to spend some time looking at some of those things that bring IoT into your facility. And one of the ways that we do that is removing intercycle wait time. High throughput facilities, this is especially important because they can't afford to have wasted time, you know, between sterilizer or washer cycles. The way we do that is by enabling push notifications that can go to one or several people's cell phones, smartwatches, things like that, to enable them to address the piece of equipment as soon as it's done with its cycle, so that we can pull that load out and get the next load in and keep things moving efficiently. And there's less time spent going back and forth to check on the status of a cycle if it's not in a commonly used room. And IoT helps enable the equipment from the HMI and the POC systems on the equipment to the devices that we all carry around with us every day. To give an example of some calculated savings, because we say, all right, how much could my lab potentially save? To look at the cost of what I've termed it as intercycle wait time. So as an example, common sterilizer cycle time could be 45 minutes. And with a 45-minute cycle time and a 5-minute load and unload time, that kind of being the basis for which I did my calculations. If you simply add 10 minutes between cycles of just downtime, so not counting the 45 minutes cycle time and load and unload time, if you add 10 minutes in between those cycles, you will get 2 less cycles per day in an 8-hour business day. And what that equates to, using this 21 business days per month, is 20% less sterilization throughput per day. And that extrapolates out to 42 less cycles per month. And it represents 2,100 minutes of unutilized equipment time. And so that's one of the things that it sounds small, but the cumulative effect of missing cycle with a small amounts of downtime in between the cycle can have a significant impact when you look at equipment usage on a monthly basis. Some of the ways that the equipment needs to improve efficiency is running the equipment operation cycles. There's often variability in cycle time that's dependent upon size, the type of media being washed or sterilized. And so because of that, the idea of setting some sort of every 45-minute alert on your phone isn't practical. And that's why the need for instantaneous updates on phones is necessary to, as I mentioned in the previous slide, cut down on that intercycle wait time, because there's no consistency typically to be able to set your time to say, hey, I need to go address this every hour, because depending on the load type, it might change a couple minutes. And as we saw, missing a couple minutes of intercycle unutilized equipment time could have significant impacts. Some of the other ways that it helps is you can also address alarms and HMI notifications instantaneously from your phone by checking on the status of the HMI and by receiving alerts when there is an alarm, so that again, it can be addressed right away and reduce the time that the equipment is just standing, especially necessary for labs and facilities, as I mentioned, with large throughput needs. The other way that you can leverage IoT to gain efficiency is by significantly reducing service turnaround time and the number of trips needed to address a piece of equipment's issue. And we'll get to that in the next couple slides. So as I mentioned, the idea of revolutionizing service is one of the ways that is significant in terms of how IoT can help at your facility. One of the things that we as autoclave manufacturers talk about a lot, is serviceability. Equipments are used, equipments like autoclaves and washers are used to serve a purpose, to serve the need of the research and production being done at the facility. So the easier it is to service that equipment, the better. And we define serviceability as just that, the ease in which you can service equipment. And IoT can help you enable ease of service. And we'll explain how as we move forward. Really up until now, service has always been reactionary. There's an alert on my autoclave, on my washer, let's address it. The equipment stops functioning, let's address it. It's all reactionary. It's looking at what has already happened with no ability to look at the future and plan for the future, both from a spare parts standpoint, but also from a budgetary standpoint in terms of service budgets. Even preventative maintenance is reactionary. Component lifespans are built around historical averages. They're not necessarily built around actual usage. So components that are used every day or multiple times per day, if you're running multiple cycles on your equipment, are going to wear out much faster, perhaps than the average, compared to someone that's using that piece of equipment maybe 1 or 2 cycles per week. So that's something to think about. There's an opportunity there to improve preventative maintenance, both in terms of part replacement, but also addressing potential issues before they arise. Let's look at a common example of service without IoT-enabled equipment. An example process, an alarm that sounds, it's not immediately solvable. It can't be addressed by the in-house staff, technicians, or perhaps an in-house maintenance team. The next step tends to be a diagnostic trip. The local service team comes in to look at the problem. Many times, service teams have a lot of equipment and tools and stuff on their vehicles as they're getting to your facility. There's many times they can't be immediately addressed. Perhaps there's not the right tools. Perhaps they need more components that they don't have. They need to order. So there's that trip. And then there's a second trip, what I've termed the resolution trip, where the service technician has the parts, has the tools, has everything they need after they've diagnosed the problem, that then they can solve the problem. The problem with this method is there's costs associated with each trip, right? And there's also a significant amount of downtime, potentially, between that alarm, the diagnostic trip, and then the time between when those parts, those tools are bought or purchased or shipped, and that final resolution trip. And all that time is wasted. That can't be recovered. An example process with IoT-enabled equipment. There's that alarm issue that starts this whole process. Instead of waiting for the service group to get in, the in-house team can call the manufacturer of that equipment, whether it be autoclaves or washers, to say, okay, I've got an issue here. There's a switch that we use on all of our IoT-enabled equipment that the operator of the equipment just flips the switch on so that our service team can wire directly into that piece of equipment. They then can do a screen sharing of the HMI, essentially like a Zoom meeting, where the operator can still see the HMI on the piece of equipment and talk through perhaps the alarm or issue that's present, but the service technician can also see that as well. And so there's a synergy there. There's a speed to which the service technician can fully look through, having been very familiar with the HMI on that equipment, to say, hey, I can look at this. This is the problem. And then that manufacturer can directly address the local service technician to say, hey, it's either A or B in terms of a problem, and these are the things you're going to need to fix it. And it helps cut down that time between the diagnostic visit from a service team and the resolution visit. And that's where IoT really starts to revolutionize and change service. Another way that it can help is backing up HMI settings. So many of our customers spend a significant amount of time customizing cycles for various load types, various processes, and it takes a lot of time. As you can see, that there's an example of some of the system global parameters that are also a part of setting up a piece of equipment for the first time. It's also important for consistency, especially on the sterilization side of things, that in terms of research and in terms of consistency and repeatability of that research, the sterilizer needs to stay consistent in terms of its cycle parameters. And if there's problems with HMIs, just like computers, there is no way to back it up without IoT. And so IoT can help by our service team or any other manufacturer service team that uses this type of technology can create a backup file of all the global parameters that are completed either at equipment startup and installation and training, or later on, perhaps the facility receives some new grants for new research and therefore needs to add different cycle parameters. The service team can go in and create backup files of those systems. So if there's an issue with the HMI, all those files are backed up, and you cut down a lot of time that would be spent on redoing those system global parameters if you lose them, or cycle global or cycle parameters if you lose them for any reason. Another example, and this is commonplace for all of us, well, probably all of us, with smartphones. Phones can do system updates in minutes, whether it's add new features, improve usability, and up until now, equipment, autoclaves, washers, the HMI, you would have to pull it off the machine to get system updates. Pull it off the machine, package it, send it to the manufacturer. They do the updates and then have to send it back. And as I point out here, without the IoT process, there's a lot of costs there. Service technicians pulling things out, additional shipping costs, not to mention equipment downtime that goes into not having an HMI on that piece of equipment. But with IoT, we can do that in minutes, just like you do on your cell phone. When Apple rolls out with a new update, you can download it, and within 45 minutes, you'll have the new update and the new iOS. Same thing applies to equipment HMI, to equipment HMI systems. You could download directly from the manufacturer a new update and have that done in the span of minutes or hours, as opposed to days and weeks. Let's talk about the benefits of an IoT-enabled laboratory with a focus on the features and how do these features work? How do they benefit you all as the people inside the laboratories, working inside the laboratories? Remote support, as I kind of alluded to earlier, the ability to connect with a controls engineering team on demand while you're on the phone is something that IoT created that frankly didn't exist before IoT enabled equipment. It allows for phone and real-time screen monitoring. So you can get on the phone with the manufacturer's service team, and through a Zoom-like screen sharing feature, you can work directly with the service team to make improvements, address issues, and you don't have to explain the entire screen. That technician who's extremely familiar with the HMI can look to solve your problems, address issues, whether it be alarms, cycle notifications, things like that. And all of that works via a 256-bit encryption, which is commonly used among the FBI and government facilities in terms of the strength of the security between the connection of the equipment and the manufacturer's service team. Another way it can practically benefit, and this is a little example of what it looks like in terms of mobile observation and even control of an equipment's HMI. It's an app integrated technology compatible with Apple and Android, but it allows you to receive push notifications of equipment updates, alarms, end of cycle notifications, as I mentioned earlier, and allows you to address them right away, whether it be taking that load out and putting the next load in, or getting in touch with the service with the local service technician if the issue can't be addressed. And it helps cut down that wait time, which is oftentimes vital for, as I mentioned, high throughput facilities. This mobile observation and control allows you to sync equipment and cycle specifications amongst different rooms and buildings, because I can go to room 123 and I can look at room 124's autoclave right from my phone, bring up the cycle parameters or the system global parameters and sync them together. And it just helps create efficiencies throughout in terms of synchronizing equipment and the parameters of the equipment. As I touched on earlier, maintenance, even preventative maintenance, has often been reactionary to either the equipment or component average lifespans, and it's not built around actual equipment usage. But IoT helps change that. Through data logging technology, maintenance plans can be built around usage. Did some math to just be able to see the significant difference between 6 months of running 5 cycles a day versus 1 cycle a day. It's drastic. And that has a significant impact on the lifespan of components, like valves and gaskets, as some of your most common high wear items. Another way that you can help address this is through autoclaves and washer logins. You can start to allocate usage to departments by analyzing who is running cycles. You can split up and accurately account for the equipment usage as you're planning budgets and stuff for your facility. As many times, cage wash rooms and autoclave rooms are used by multiple different departments, and there needs to be some sharing of cost and allocation based on usage to each of those departments. It also helps you develop accurate service budgets, because you can start to plan when you'll need valve replacements based on cycle usage as opposed to simply time, an average period of time, which may be too fast or too soon in terms of component replacement, depending on your usage compared to the average. It also helps store the cycle data and equipment history of that autoclave or washer. While we aren't eliminating printers, because it would have a significant impact on some facilities and their need for digital print or for hard copy printouts, we can back up all the cycle information onto a flash drive that you could then analyze and store digitally, and it helps cut down on big containers full of cycle printouts. And it also helps make them easier to to spot trends in terms of cycle times growing longer, which is typically an indication that a valve might need to be replaced or addressed. As I mentioned at the beginning, we've kind of talked about the need for efficiency, how IoT can help on efficiency in terms of notifications of equipment usage, cutting down on service costs and time. And the last thing is, hey, how do I get IoT into my facility, especially if I'm not looking at new equipment in the near future? And we'll talk about some of those options now. The important thing in understanding all these implementations is to understand the security that we use and that is commonplace in the industry in terms of enabling IoT in your facility. Because as I mentioned earlier, we use 256-bit AES encryption, but what does that mean? And so upon doing a little research, even if you use this supercomputer, the fastest supercomputer in the world, basically guessing at the encryption code, it would take millions of years to crack 256-bit AES encryption. saying that. So that's the security. These are the implementations. The first is somewhat obvious. It's hardwired, right? It's just as you would with your computer. If you're plugging in, there's a box that's added to the equipment where you can hardwire a standard Ethernet connection right into your piece of equipment, and that enables IoT capabilities throughout. It also, with this method, it comes with two security options. The first one is on all of our equipment, there is a manual on-off switch that you can turn on and off when you don't want outside connection to the piece of equipment. So to speak in terms of reality, if there's an issue, you want to connect with the manufacturer service team, you can simply flip the switch from off to on, call that service department, service team, and they'll be able to see the HMI and address the issues with you. And then when that call is done, you can flip it back to off, and the manufacturer no longer has access into that piece of equipment. And it helps protect against vulnerabilities. The other way is you just simply unplug the Ethernet cable, and there won't be any connection. So it's another additional security feature, as there's often some hesitation towards allowing an outside access point into internal networks, into internal pieces of equipment. As I mentioned, this and all the others is connected by 256-bit encryption. It's used by FBI and other government organizations. So it is the most common and strongly used encryption connection available. The other option is a cellular connection. So some reasons why this might be needed. If there's not an Ethernet connection to a particular lab, you're not knocking out walls, you're not running cords down the hallway to enable this type of IoT-enabled functionality to your equipment. It works the same way that your cell phone would. And one of the things that it helps do is it helps eliminate internet vulnerabilities. So you're not allowing that equipment manufacturer service team to connect into your network through that Ethernet connection. It's simply operating separately. So essentially what it would be is a Verizon, a Sprint, Sprint and T-Mobile are now one, but AT&T being another one. You purchase a SIM card, you purchase access to that, and that way that SIM card only is speaking directly to the outside world, and it has no impact or connection to the rest of the facility's internet connection. Another thing that's important to think about in terms of, hey, how do I protect my equipment from potential hackers? There's always the ability to simply remove the SIM card from the connection point inside the equipment. You'll see that kind of throughout. There's a manual point of access that helps protect the facility, the piece of equipment from potential hackers. And that's an important part of us as we design this system, making sure that you are protected from any digital threats. The SIM card also uses 4G technology, and we'll use 5G as it starts rolling out in many cities across the US. And to give a comparison on what 5G would do for just the speed of that service help, a CNN article citing numerous industry experts noted that the 5G connection is expected to be 100 times faster than 4G. So if you have 4G enabled on your phone in terms of speeds of downloading videos, 5G will be 100 times faster than that. So it will help enable service teams to quickly see the HMI and the potential issues that you may be having with your equipment. The last connection point is what we call a machine-to-machine connection device. It works kind of like a suitcase or a briefcase, but it is a portable connection center. It has, as you explained with the SIM card, it has cellular technology built within it, but essentially the service technician or the facility maintenance team will be able to bring this device in, connect it directly to an Ethernet connection port built into the front fascia right under the HMI. And what that helps do is enable only on-demand access to the piece of equipment. It's secure because it operates on a cellular signal and is completely separate from the local connection, but it also is on demand in terms of it's not connecting unless this machine-to-machine device is plugged into that Ethernet connection on the front of the machine. That's our IoT enablement. Again, to summarize, we talked about the needs for efficiency, cutting down intercycle and service wait time, some of the benefits in terms of mobile observation, technical support, preventative or predictive maintenance, replacing preventative maintenance in terms of data analysis of cycle usage that the manufacturer can then make suggestions on when to replace valves and components. And the last part is the application. How do I get it to my equipment when it's not new? And those are the things we touched on today.